Hi, and welcome to using CPK as a tool to control measurement risk. Here we have an example with 95% measurement confidence. The measure value is 1000.75. Calibration using tolerance limits could yield significant risk and cannot ever completely cover all the process risks that you face. Thus, we are left with traditional option that we can apply a guard band, or we can pay attention to our CPK value and control the associated measurement risk. If the goal is 95% measurement confidence, a CPK value of 0.667 is going to control your risk. Here we are moving the measurement value to 1000.8. The measurement is still within the tolerance limits, and yet the risk is higher than 5%. And our CPK is less than the 0.667 we want it to be. CPK? What is CPK? CPK is a statistical tool to measure the ability of a process to produce output within the tolerance specification limits. In metrology, a CPK of better than 0.667 at 95% confidence is considered acceptable. Let's review. What does traditional CPK math look like? The traditional formula just tells you to measure the distance from your current process location to both of your process limits. The CPK formula for metrology is a bit different. In metrology, we're using the minimum of the upper specification limit minus the measured value divided by 3 times the standard uncertainty, and then we're using the measured value minus the lower specification limit divided by 3 times the standard uncertainty. The traditional CPK formula gives no hint as to the best size dataset to provide your process average. Guessing wrong on that size will send you into the weeds very quickly and also hide risk. Another weakness is the unspoken assumption that all the data that we use for calculating CPK does not have uncertainty. We know that all measurements have uncertainty. Therefore, the modified formula for metrology uses the specification limits, location of the measurement, and the measurement uncertainty to calculate CPK. Here we're going to show a table for K equals 2, or 95.45% measurement confidence. You can see we've kept the CPK the same, and we've varied the standard uncertainty. We're showing you TUR, lower limits, upper limits, and the risk associated. And you will notice using that constant CPK that our risk never exceeds 2.28%. Here are some good ways to limit your measurement risk. You can use a calibration supplier with the lowest uncertainties. Continual improvement of the calibration processes. Utilizing the appropriate reference standards, SPC, another good method. Calculating measurement risk using CPK formula for metrology, as we discussed earlier.